Question number 2B, trial number 1, it goes, a reception of an office has two computers A and B. The probability of computer A failing is 0.15 and the probability of computer B failing is 0.25. Determine the probability that Roman 1, both computers are working. Roman 2, both computers are not working. Roman number 3, only one computer is working. And Roman number 4, at least one computer is working. So before you start calculating this given problem, before you start solving it, you need to draw what we call a tree diagram for this information. So welcome to this tutorial, and let us start by drawing the tree diagram. Then you say a reception has two offices. A reception of an office has two computers, computer A and B. So this one will be computer A, computer A and B. Let me draw it here. Computer A and B. And before that, let us say that let the probability of computer A failing not computer A, of a computer failing be F, and the probability of a computer working be W. So we have two computers, computer A and B. So the probability of computer A working and failing, computer A failing is 0.15. So it is 15 over 100. And the probability of computer A failing working is 85 over 100. And then computer B, the probability of computer B working failing is 0.25, which is 25 over 100. And the probability of computer B working is 75 over 100. So this one will be sharing a half and a half. So this one is the tree diagram for the above representation. And then question number 1, determine the probability that both computers are working. So the probability that both computers are working, probability in bracket P, both computers are working, is equal to probability of A W plus probability of B W. So you get your answer as a half. A half times 85 over 100 plus a half times 75 over 100. So you get your answer as 160 over 200. 160 over 200. So that is the probability of that both computers are working. And then Roman 2, both computers are not working. So the probability that both computers are not working, it gives you the probability of failure. The probability of failure, which is equal to P, probability of AF plus probability of BF. The answer is equals to a half times 15 over 100 plus a half times 75 plus 25 over 100. 25 over 100. So the answer is equals to, the answer is equals to 40 over 200. And then Roman 3. They determine the probability that only one computer is working. Only one computer is working. Only one computer is working. So it is either computer A or computer B. So you say probability of A or B. So the probability of A or B working is equal to probability of A or B is equal to the probability AW plus probability BW minus probability of AW combination probability ya BW. So you get your answer as 85 over 75, 85 over 100, 85, AW is 85 over 100, AW is equals to P, AW, which is a half, times 85 over 100 plus BW, which is equal to 75, a half times 75 over 100 minus probability here AW is an A intersection. So it's an intersection of A half times 85 over 100 times a half times 75 over 200. 25 over 100. So from there, you're going to get your answer after doing the calculation there. And then Roman number 4. Roman number 4. You say at least. Calculate, determine the probability that at least one computer is working. So probability that at least one computer is working is it is the probability of A and W. So it's probability of A and maybe say and W, A and W, which is equal to probability of AW times probability of BW or is this one. So you get your answer as a half times 85 over 100 times a half times 75 over 100. So you do your calculation, you get 85 over 200 times 75 over 100. So 85 times 75, you get answer as this one times this one. You get answer as 25. Say 5 is 85 times 75. You get 25 carry 2, 42. This one 35 plus 2, 37, carry 3. 5 times 8, 7 times 8, the answer is equal to 56. Which is 45 times 8, 56 plus 3, which is equals to 59. So you get your answer after doing the calculation. You get your answer here, which is what? 85 times 75 over 40,000. So that one becomes your answer. So thank you very much for watching this tutorial, and I hope you are going to subscribe and get the notification for more. I'm Jay Rasmbulu. Thank you for watching the video.